In this video, we are graphing quadratic functions or parabolas. So those U-shaped graphs that I was talking about in a previous video. So given the function f of x equals x squared plus 4x plus 3, we're going to find the following and then graph the function. So our first A part is asking for the leading term. So remember, the leading term is the term with the highest exponent. In this case, that's going to be that x squared. So our leading term is x squared. From that, we get our degree, which is that highest exponent. So in this case, that would be 2. So again, thinking back to that in behavior, if we have a positive even degree, we are looking for a parabola that has both sides going up. So if we're going up, the y values are going to infinity. So in behavior, as x approaches infinity, f of x, or y, also approaches infinity. So it's going up. And as x approaches negative infinity, f of x, or the y values, are also approaching infinity or going up. Okay, now parabolas, we can now consider what happens in the middle. We want to know what's going on, what's this bottom point that we're looking at here. So we're going to go ahead and connect these and make a U shape. So this is kind of the shape we're looking for, and knowing that both sides go up gives us an idea that this U shape is going up. So does the parabola open upward or downward? This is opening upward. Now, the next concept you need to know is that this very bottom point here is called the vertex. Okay? And if I was to flip this over, it would be the top point, but we're not there yet. We'll do that in the next example. So this is asking, does the parabola have a maximum or minimum? So maximum would be a high point, minimum would be a low point, the lowest point on the graph. And in this case, the graph is all above this point. So this vertex is the lowest point. That means this is going to be a minimum point. Okay, and now we approach the first formula you need to know in order to graph parabolas. That is the vertex formula. So we want to actually figure out what is this point so that I can graph it, and that will be the first point that we graph. Our vertex formula is the x value of minus b over 2a, and then the y value is saying, hey, do f of what you just found. So this means plug in x into f of x. Okay, so let's walk through this process. So first, we have to find x. That's the order of this. So x equals negative b over 2a. Notice that I'm putting that negative. It's out front in the formula, but I'm going to put it in the numerator for this. Next, we need to find our ABC, and it's the same ABC that we found when we were looking at quadratics in that standard form. So A is the number in front of x squared. That's going to be 1. B is the number in front of just x. That's going to be 4. Okay, and we don't need C right now. So this would be, plugging this in, we would have negative 4 over 2 times A is 1. So this would be negative 4 over 2. Simplifying that, we get negative 2. So that is our x value. And again, this is a point that we need to plot. So our vertex is going to have an x value and a y value, and we know now that our x value of this point is negative 2. Great. So I've talked a bunch about this in previous videos, but if we have an x value, how do you find the y value? Especially when we're dealing with functions. If you have an x, you plug in to the function to find the y. And that is what this is saying. It's saying you just found negative 2. Now find the y value, which is going to be f of negative 2. This means plug negative 2 in. So we're going to do that. We're plugging it into f of x. So this will be negative 2 squared plus 4 times negative 2 plus 3. And what will that give us? That's going to be 4 minus 8 plus 3 is negative 1. Y'all double check it in your calculators. Okay, so that means that our y value is negative 1. Okay, let's go ahead and plot this vertex. So we've now found this bottom point negative 2, negative 1. Let's plot this. Negative 2, negative 1. It's going to be right there. Okay, so that's our vertex. Now, for the sake of the graphing this on my computer, you need at least one other point. Okay, there's a couple different ways you can do this. I'm going to show you one kind of methodical way, and then I'll show you kind of an easier way. So let's talk about how we find one other point. Now, you could technically pick any x value you want. This is kind of like making that xy chart when we were graphing lines. You could pick any x and y value, or any x value, and plug it in to find a y value that you want. However, just like with lines, if you pick certain values, you're going to be off the graph. And the way parabolas work is the further away you get from this vertex, the higher it's going to be. So my advice would be only go 1 unit from the vertex. So we want to know what number is 1 unit away from the vertex. So let's look at this. 1 unit away gives us the gives us the x value of negative 1. Okay, so one more time. Look at the vertex, go 1 unit to the right. You could go 1 unit left, that's fine too, but I always just go 1 unit to the right. Okay, so this is giving me the x value of negative 1. How do you find the y value? What did we just do in the previous part? Whatever you find for x, you're plugging it in to find y. And this is no different. So we are now going to plug in f of negative 1 to find the y value. Again, back in the function. So this would be negative 1 squared plus 4 times negative 1 plus 3. Put that in your calculator. You get 1 minus 4, which is negative 3, plus 3, and you get 0. So this is another point we need to plot. Points have x and y values. Our x value is negative 1, y value 0. Okay, so let's plot this. Now, I did not intend for this to be arrows that worked out like that, and it will not always work out like that, but this point right here is going to be our other point that we need for graphing. Now, let me make this clear. In the computer, typically they want you to graph the vertex and one other point. So this satisfies that requirement. This does not really help us that much on graphing this on paper, but we can kind of think of this and know that this is going to give us a U shape on the right-hand side. This should not be a line. This is a curve, so it's a U shape. And the other thing is, and we're about to talk about this, it's going to ask for axis of symmetry. This has symmetry, okay? So whatever I do on the right, I can do on the left, and it should kind of match up. That's not a great example because my drawing's off. But what do I mean by that? Here I went from the vertex, I went up 1, right 1. I can also go from the vertex up 1, left 1, and that gives me another point that is symmetrical to the point that I graphed. And that will give us my left side, or our left side of the parabola. Now, again, one more time. In the computer, you don't need the third point. You don't need to actually graph the third point. The computer will take care of the left side for you. You will graph the vertex first and one other point, and that's enough. Okay, I'll tell you the shortcut way here in just a second, but let's continue. So H part says, graph the parabola using the vertex and points. Did that. What is the maximum or minimum value? So we talked about that this is a minimum because the vertex down here is the lowest point on the graph. Okay, so the lowest point on the graph is a y value. So what is the y value of the lowest point? Well, this would be the y value of the vertex, and in this case, that y value is negative 1. So our minimum value is negative 1. Okay? Then it says draw the axis of symmetry. So just like I did up here where I drew the axis of symmetry, we want to do that on the graph. The axis of symmetry is going to go right down through the middle of the vertex. It's basically cutting it in half. Okay? So we're going to go right down through the middle of the vertex. Then it says, what is the axis of symmetry? So we need to think about, what did I just draw? I drew a vertical line, okay? A vertical line. So I'm not just looking for the x value here. I'm looking for the equation. This is going to be the equation of the line that is the vertical line. And if we go all the way back to graphing lines, what's the equation of a vertical line? Remember, it's whatever x value it is. So this is going to be x equals the x value of that line, which is -2. You have to put the x equal. That's what's making the equation. If you just put -2, it's going to count it wrong, because -2 is not an equation. It is not a line. Okay? Hope that makes sense there. Now, let me talk through the easier way, maybe. I've had about half my students like this way, about half my students like to just do it like we did here. Easier way to do this. All right. There's a relationship between 1 unit over from the vertex and a in the function. So a right now is 1. If you go 1 unit over, that gives you how far up you're going. Or you can also think of this as rise over run, but this is not a line. I want to make that clear. Okay, so if a is, let me write it right here. If a is 1, then think of this as rise over run, but this isn't a line. This is only going to get you 1 unit over. You cannot use this past that, okay, because this isn't a line. It goes up a lot quicker. The relationship changes. Okay, but this does give you the relationship between the vertex and 1 unit over. So if I do rise over run here, this goes up 1, right 1, and that gives you your other point. Okay, so you can do that. A is always going to do that for you. I'll show you in the next problem, but if that was, real quick, if A was like 3, you would go up 3, right 1. You're always going to go right 1. If A was -3, you would go down 3, right 1. Okay, so your relationship is always 1 unit over, but this is telling you how far up or down to go from there. Okay, all right, so that was one example. Let's do one more. All right, this is saying find the vertex and graph the function below. The function is -2x squared plus 8x minus 4. So this isn't asking all those questions that I was kind of leading you through in the previous problem. This is being far more straightforward and saying, you figure it out. What do we need to know in order to start graphing this? Well, first, it might be helpful to know which direction this is pointing. So this goes back to leading term. Our leading term is -2x squared. Our leading coefficient is negative. That means this parabola is going down. And we can actually connect this together if we want to. That means our vertex is up here. Okay, that means this is a max. All right, so we know that when we start graphing this, it should be turning down and it should look, it should have a maximum for the vertex. Next step, find the vertex. Okay, I took away your formula. So what do you need to know for this? You need to know the vertex formula. So x equals -b all over 2a. Next step, plug in. So a is -2 in this, b is 8. So this would be -b, which is 8, over 2 times a, which is -2. Be very careful with the signs here. This is where I commonly see people mess up, and you mess up this, and now it's going to just kind of trickle down effect, okay? So this is -8 divided by -4. Simplify that. 2 negatives make a +2. Okay, so that's giving us the x value of the vertex. How do I find the y value? We're plugging it in. So y is f of 2. And I need you to be so careful because a lot of you missed this when we did previous problems because of the negative signs. This is -2 parentheses 2 squared plus 8 times 2 minus 4. So be careful putting this into the calculator. This is going to be -2 times 4 plus 16 minus 4, and that gives me 4. Okay? All right, so that's my y value is 4. So let's graph that next. 2, 4. Great. All right, next, 1 point does not make a parabola, so we need another point. Let me talk through using A real quick, and then we will go through using a point. So A is -2. Do that over 1. -2 over 1 means go down 2, right 1. Down 2, right 1. Let's put a point there. Okay, down helps us because this is turned down. And so this should be turned down. And you can kind of do the same thing down to left 1 to get on your paper the other side. And again, this should be a U shape. It's kind of hard to do when that number is pretty big. All right, so that's the graph that we're dealing with. Now, what if you didn't want to do it that way or you're confused about that way? Then you're looking at your x value of your vertex. That's going to be 2. And you're just adding 1 to it. So x value of the vertex is 2. If I add 1, sorry, yeah, that's right. If I add 1 to it, that gives us the x value 1 unit over. So that gives us this 3. Now that I've got an x value, how do I find the y value? You plug in. So y equals f of 3. And let's plug in and see what we get. This is -2 times 3 squared plus 8 times 3 minus 4. So this would be -2 times 9 plus 24 minus 4, which is going to be 2. So what point did I just find? The x value is 3. The y value is 2. Let me check that. So 3, 2 actually happens to be that point. So it really doesn't matter which way you do it. You're going to get the same point. Okay? Hope that was a little bit helpful there. I don't care which way you do it. Pick one. All right. Axis of symmetry. Axis of symmetry is going right down through the middle. Axis of symmetry is a line. It's a vertical line. A vertical line always starts with x equal. So you have to have the x equal, and what x value is it going down through? It's the x value of the vertex. Okay, so whatever this is, that's going to be what you're putting there, but also you can clearly see that it's going through that too right there. Lastly, we're asking for max or min value. It doesn't really make you choose that, but clearly this is going to be a max. So this max is the y value of the vertex, okay, because this is the y value here of 4. Now, you don't have to put y equals there because this is just asking kind of like the height. What's the max height, okay, of this? What's the highest y value here? And that does not include a line. Even though I'm drawing a line, it's not asking for that. It's asking what is the y value of that point, okay? So this max value here is just 4. And that's it.